called resources. So if you go in to print off notes or look at recorded lecture, I also put this note or this link called resources, and there's a link to the OTC Math resource page, but I specifically linked it to a college algebra resource page. So Melissa Whitmer is an instructor here. She also teaches for Cox College, and she put together, a couple years ago, she put together these college algebra lessons. And the 4 topics we'll talk about are here. So we're talking about polynomials and rational functions now. And so she has these subpages. So, you know, how to graph a polynomial function. So if you are struggling with ALEKS or your homework, or something I say in class just doesn't click, watching me say it again is not going to make it click necessarily. So she's put together these interactive PDFs you can go through, and then there'll be tutorials embedded within them. So kind of a lot like I give you, note-wise, and it's from our book. Here's the notes if you want to grab one for today. And you can actually print these off and also watch, you know, video tutorials. So ALEKS has support, you know, explain this to me, watch it, you can read your textbook. You have all these different resources, hopefully to give you the tools you need to pass the scores. So sometimes I lose you in class because maybe you missed the day or you have a lot going on, and I see that. So it's kind of your responsibility to use these resources and make sure you understand the material, because I can only do so much in the 50 minutes that I have you for. So there are other, if you go to the this resource page, if you just click on college algebra, it takes you to different links to different people's pages. The first one takes you to Khan Academy, which I don't know if anyone has seen Khan Academy before, but it links to videos, and they're just kind of shoot from the hip. Here's a quick example. So if something's not clicking, it might be worth your time to kind of look. And of course, you could spend all day doing this. So I tried to also just kind of point you to, this one is an instructor OTC who taught out of this book and used the resources from this book to create those videos. So they're going to be more in line with your textbook and your notation. So last time we left off with basic graphs. We didn't talk too much about factoring because I assumed you know how to factor from Math 110 or Math 050 or 040. Basic factoring. We didn't go into anything more in depth. I was going to give you guys this in class kind of activity, but I'm going to give it to you as a take-home quiz at the end of class. We don't have class on Monday because it's President's Day, and the college is doing some faculty stuff on Tuesday, so we'll meet back on Wednesday. This will be due next Wednesday. I just wrote take-home quiz 3 on it, and I'll pass this out towards the end of class, and you can write due Wednesday on it, due in class. So it's going to be a lot like your ALEKS type stuff, but I want to be able to grade something, give it back to you before you take exam 2. That's a good question. So if you go to the schedule, it is going to be, yeah, March 4th. And it's going to be the week before spring break. So it'll be the Wednesday before spring break. So hopefully I have it graded and give it back to you by that Friday. And then you can kind of start 4-1 before you go on spring break. Today, we're going to look at, the whole point of chapter 3 is, can you sketch the graph? The first thing they kind of introduce is, can you sketch this graph of a polynomial? So we wanted to focus on end behavior. And then we want to focus on zeros of the polynomial. That's where it crosses the x-axis. We find those zeros by factoring the polynomial and setting it equal to 0, putting each factor equal to 0 to see what number makes the corresponding factor equal to 0. And then we can talk about the multiplicities and all that kind of stuff. What we're going to do today is look at polynomials we can't factor easily. So And 3.2, we focus on polynomials we could factor by grouping, or that were quadratics. Essentially, we could pull out the terms to make it quadratic, and we can factor a quadratic. But today, we're going to learn what happens when we have no tools to factor that. And the technique we use to factor is called long division or synthetic division. So we're going to learn both types of approaches there. So given any polynomial or any function, we can always write it by the divisor, let's see, what does it say? What does it just call it? The dividend, divisor, quotient, and remainder. So if we take the dividend times the quotient plus the remainder, we get the original function. And ideally, we want the remainder to be 0. That's when we factor it. When the remainder is not 0, then that tells us the input is not a factor, or the number we're dividing by is not a factor. So let's just look at this technique for the first couple ones, and then we'll actually apply it to factor polynomials. So long division, we're looking at a third-degree polynomial, and we're dividing it by a first-degree polynomial. So this is x minus 4. If this remainder is 0, then we've shown 4 is a factor, or this x minus 4 is a factor. So 4 would be the 0. So setting this up just like long division of numbers, I can have x minus 4 divided by 3x cubed minus 11x squared. And then I'm going to go ahead and put plus 0x minus 10 as a placeholder. That's going to come in handy because I want to keep everything in order. Some of you are looking not too sure. So this is my number that my divisor, my dividend. This is what I'm trying to, my polynomial. So I just start this. Here's what I need to put in, that when I multiply it by x, I get 3x cubed. So what times x is 3x cubed? And that would be 3x squared, right? 3x squared. So 3x squared times x would give me 3x cubed. So then I distribute this to each one of these terms. So I take 3x squared times minus 4. So this would be minus 12x squared. And then I subtract them, and that's important. I want to subtract them because I set this up so that this goes away to 0. Right? So what's minus 11x squared minus a minus 12x squared? Positive x squared, right? Do you guys remember doing some of this? No. Never. You've never done it with polynomials, but you remember doing long division with large numbers. If I say what's 2 divided by 1, 3, 6, 9, 7, 8, I would say, what do I need to multiply by 2 to get 13? So if I multiply that by 6, 6 times 2 would give me 12, and I subtract that, I'd be left with 1, 6. You guys, middle school maybe, pull that down deep, doing something like this, long division with numbers. We're doing the same thing, except we're doing long division now with polynomials. So we're looking at each term. Here I'm looking at, what do I need to multiply by my first term to get 3x cubed? And I need to pick that to be 3x squared.
How did you get x squared again?
Right here?
Yeah.
Or right here?
No, below.
This?
Yeah.
Okay, so here I would take what's in this box. I need to multiply it by both these terms.
Right.
First I multiplied it by x, then I multiply it by minus 4. Right. So I have a minus 12x squared. Right? Then I subtract them. This goes to 0. And I have minus 11 minus minus 12. So it's really plus 12. Okay. This is an important thing, is you distribute this negative. So a negative minus a negative is really adding. So that gives me x squared here.
Why do you have the 0x minus 10? The first
Here
part, yeah.
or here?
I missed that.
This
No,
0x?
up there, right there. The
Really,
0x
there is a
minus 10.
plus 0x here, minus 10. If I want to write this polynomial, if I want to write every single term, minus 11x squared plus 0x minus 10. These are kind of my significant terms, my placeholders. So since I have an x here, when I multiply that by a number, I'm going to get something x.
So you just put it there to even it
Keep
out.
everything
Okay.
in line. And that's going to be very, very, very important when we get to synthetic division. Because if you don't, it's kind of like your tens column, your ones column, your hundreds column. If you mix those up, it's not going to make sense. This is your x cubed column. This is your x squared column. This is your x column. So there's 0 in it to start with. But it doesn't mean that there's not going to be some in the quotient. So you guys see that first step and where I picked 3x squared?
I missed that actually.
Okay, so this first step,
And then it multiplies with x, obviously make 3x cubed.
that's why I picked it, because I want to get rid of that 3x cubed.
So what? I guess I don't understand why you're picking 3x squared.
Because 3x squared times x is 3x cubed.
How did you pull it out? I guess is what I'm trying to figure out. Why did you choose 3x squared to pull out? I mean, I understand that it multiplies up to 3x cubed.
Well, I can pick whatever I want up here, but I want to pick the closest thing that's going to get rid, I want to pick the number that's going to get rid of 3x cubed.
And that would be just the highest degree term then?
That's all I worry about is the highest degree term I'm on.
Okay.
So right now I worry about 3x cubed. What do I need to multiply by x to get 3x cubed? And that's 3x squared. So I do that, that messes with my x squared term, and I'm left with an x squared, right? So now, what do I need to multiply? So I add something that I multiply by x to get x squared. X, right? You guys see that? So I picked x because I want to get rid of x squared.
Okay.
Because that's now my highest term, because I got rid of the x cubed. See that?
Yeah.
I'm going to go ahead and drop the plus 0x, because now when I have that x, I multiply it by x, and I multiply it by minus 4. So x times x is x squared, which is exactly what I wanted it to be. X times minus 4 would be minus 4x. Then I take my parentheses and I put a negative out front. If I don't do that, oops, where'd it go? Sorry. If I don't put this negative out front, then I have 2x squared, and I don't want that. I want to subtract them. So that gets rid of that to 0. Right? X squared minus an x squared is 0. Because x times x was x squared. X times minus 4 was minus 4x, but I have that negative out front, so I have 0 minus a minus 4x. So that gives me plus 4x, right? Go ahead and drop the minus 10. So what do I need to multiply by x to get 4x? 4, right? So I'm going to say plus 4. So 4 times x is 4x. 4 times minus 4 is minus 16. Put the negative out front. This gives me 0. And this gives me 6. So 6 is my remainder. So my dividend is my original function. My divisor and my quotient, this up here is going to be my quotient. This 3x squared plus x plus 4, that's my quotient. My remainder is then this 6. So I could rewrite this as 3x squared minus 11x squared minus 10 equals x minus 4 times 3x squared plus x plus 4 plus 6. So if I FOIL this out and add my 6, I get the left-hand side.
Square root of cubed.
3x squared, yes, thank you. 3x cubed right here. 3x cubed. Yeah, and these arrows don't really mean much. I'm not going to ask you to necessarily classify what's the quotient or what's the dividend or what's the divisor question.
I'm sorry, I didn't understand last night. Why did you choose +4?
The x plus 4? That is my, I mean, x minus 4.
I'm sorry, I mean, you're factoring out there. The division. Right there.
Why did I pick plus 4?
Yeah.
Because I need to get rid of this plus 4 here.
Wait, are there on the top, are there 2 plus 4s?
No. So you have 3x squared plus x plus 4. Let's look at another one. Let's look at an important thing when you set these up is you always write the highest power to the smallest power. And if there's any powers missing, put 0 that power to keep everything straight. So let's look at doing this x plus 2. And then I want to write 4x to the 4th minus 12x cubed minus 27x squared plus 30x plus 8. So here I have all 5 terms. So the first thing I'm going to ask, what do I need to multiply by x to get 4x to the 4th? 4x to the 3rd, right? Once you pick that, your next 2 terms are set. 4x to the 4th plus, what would it be? 8x cubed, right? So now it's math. Now it's just adding and subtracting. Zero term here, minus 12 minus 8. So this would be minus 20x cubed, right?
So would you,
I would take minus, minus, plus. So a minus, minus. Yeah. So you have to be careful with this. Question? So just by picking that 4x cubed, I canceled out all my x to the 4th, and I have to deal with this minus 20x cubed. So what do I need to add up here that when I multiply by x, I get minus 20x cubed? Not 5x squared. What times x is minus 20x cubed? Yeah, minus 20x squared. Because that times x would be minus 20x cubed. You guys see that? Question. You don't have to put a, you don't have to put the plus. You don't even have to put the box. I just wanted to put the box as you can see all the blue goes with the blue and all the purple will go with the purple, and whatever color I pick next will be grouped with that. Once you pick what's in the box, you're set as far as what's happening underneath. You have no control of that. You pick that to go in the box to come out conveniently to cancel this minus 20x cubed. So if I do that, I have minus 20x cubed minus 40x squared, right? So I might go ahead and drop the minus 27x squared just so it's easier to see. And then you always want to put a parentheses and a negative out front. If you don't do that, you're going to get them wrong because you're really subtracting. So this goes to 0. Minus 27 minus a minus 40. Plus 13, right? Plus a 13x squared. So what do I need to add up here? That when I multiply by x, I get 13x squared. 13x, right? So this would give me 13x squared. What would be my next term? plus 26x. You guys see where he got that? Because 13x times 2 is 26x. So now I subtract those two terms. I get 0. 30 minus 26, 4x. So I could go ahead and drop my plus 8. And just because I know I'm going to have to deal with two terms because there's two terms in this polynomial. So what do I need to multiply by x to get 4x? 4, right? So plus 4, that gives me 4x plus 8, and then when I subtract that, I get 0. Which means x plus 2 is a factor of this polynomial. That means I can write out this polynomial as 4x to the 4th minus 12x cubed minus 27x squared plus 30x plus 8. I could write that as x plus 2 times 4x cubed minus 20x squared plus 13x plus 4. So if I wanted to find the zeros, setting this equal to 0, I can get one term there. If I plug in minus 2 into this polynomial, I get 0, which tells me minus 2 is a root, which tells me I'm going to cross the x-axis at minus 2. So I was able to verify that by showing the remainder 0. That's where we're leading to with this long division. We're leading up to being able to show a number is a factor. If you can plug in the number into the polynomial and get out 0, you know it has to cross the x-axis there. If you do long division and your remainder 0, that tells you it's a factor. You can do the same thing with these polynomials using synthetic division. You can see how long this is. Using synthetic division, you take out all the x's. And you know this column is the x to the 4th column. This column is the x 3rd column. This is the x squared column. So this is the same problem. No, this is a different problem. So this problem here, I could divide this polynomial by x minus 2. Or synthetic division is putting the factor here, listing the coefficients of a dividend. You drop the 2. You always drop the first term. Then you take 2 times 2 to get 4. And here you always add. So what's 3 plus 4? That's 7. So you take 2 times 7 and get 14. And then you add and you get 0. So you can see how this is a lot neater. It's a lot tighter. The same information is here as it is here. This is your coefficient of your quotients here, or this is your quotient. You guys see that?
Why does it, you don't use the minus 2 though? You just use the
That's a good question. So this is where x minus c, if you're dividing in this form, x minus c, you put c here, and then you have the function, and you go through there. Since the negative is outside of the c, then you add them, because the negative is always,
so
it's
you
already
just do
taken
the
into
opposite
account.
Just to make it
Yeah, you
easier,
can
basically.
you can think of it that way. So let's look at this example here. So we want to do synthetic division. So this is really x minus minus 1. So our c here is minus 1. So if I do synthetic division, I'm setting this up. My c is minus 1 because I have to be in the form x minus c. So if it's in the form x minus c, then c is minus 1. Because really this is x minus a minus 1. So c is playing the role of minus 1 there. So then the next thing on synthetic division, I write my highest power term first, and I write the coefficient of that. So I have minus 2, 5. I don't have an x squared term, so I write a 0 there. 2 and minus 5. You guys see that? That is my kind of my setup. Before we would have an x to the 4th, an x cubed, an x squared, an x. And then of course we'd have pluses. But with synthetic division, we don't need the x's. We know that this is our x to the 4th column. X 4th, x cubed, x squared, x, and our constant. You guys see that setup? Now, synthetic division, the very first thing you do is you always drop that first number, minus 2. Then you have to come up with what goes here. To get that, you always take this number times this number. So it's minus 1 times minus 2. 2, right? And you always add. So 5 plus 2, 7. How do I get this number? I take 7 times minus 1, which would be minus 7. So I have minus 7. What's minus 1 times minus 7? Positive 7. That gives me 9. Minus 1 times 9. Minus 9 plus minus 5 is minus 14. So that's my remainder. You guys see that? So then this would become minus 2x cubed plus 7x squared minus 7x plus 9.
Because you put your x's just back in that.
Yeah. It's what's known as the quotient. People tend to like synthetic division because it's just, it's the exact same math though. If we went over here and did long division and I have x plus 1 and I have minus 2x to the 4th plus 5x cubed plus 0x squared plus 2x minus 5, I'd say what do I need to multiply by this? Minus 2x cubed. I'd have minus 2x to the 4th minus 2x cubed. Subtract that. I'd be with, what would that give me? Minus 7x cubed. Positive 7x cubed, yes. Plus 7x squared. So this would be 7x cubed plus 7x squared. That would give me minus 7x squared again. You see that? It's going to be the exact same thing. I get minus 2, 7, minus 7. This is the exact same math. It's just taking out all the x's and keeping it in the right row. All you have to do is worry about the numbers. The most important thing when you do synthetic division is make sure you know what C is. What is C is? What is C in this case? Negative 2, right? Minus 2. So if I do synthetic division here, I have minus 2. Then I set up 1. So this would be my x to the 5th. 0x to the 4th. 0x cubed. 0x squared. 0x. 32. You guys see that? Really, it's saying x to the 5th plus 0, x to the 4th plus 0, x cubed plus 0, x squared plus 0x plus 32. The zeros are just understood. If you leave out a power of x, then you assume that the coefficient's 0. So now I do synthetic division. I always drop the first number. Then I take my C times that number to get this number. So it'd be minus 2, right? I'm adding. Be minus 2. This would be minus 2 times minus 2. Positive 4. Minus 2 times 4. Minus 8. positive 16, minus 32. So that tells me 0. Tells me x plus 2 is a factor of x to the 5th plus 32. Right? So I could write x to the 5th plus 32. I could write that as x plus 2 times x to the 4th minus 2x squared plus 4, x cubed plus 4x squared minus 8x plus 16, right? You guys see how those are just the coefficients of the x to the 4th, x cubed, x squared, x, and constant term? You can see that? You'll be asked in this section to verify if minus 2 is a root, or verify that x plus 2 is a factor. One way to do that is synthetic division and show the remainder 0.
What are those lines mean?
It's just the remainder.
Oh,
Sometimes it's just kind of say that it stops there and it has remainder 0. Maybe, circle it as the remainder. Our whole goal in this objective in synthetic and long division is to show the remainder 0. When the remainder is not 0, we've kind of wasted a lot of time because we're not anywhere new. If we can show the remainder 0, I've gotten 2 factors. So I've decreased this 5th degree polynomial to a 1st degree polynomial and a 4th degree polynomial. And as much as you can decrease the power down, it gets easier and easier to factor. And then we'll use this technique with the rational root theorem that tells you any possible factors. So if you know only 8 things are possible to be factors, you can test them really quickly to see which ones are factors and which ones are not factors. You guys see that? Ideally, we want our remainder to be 0 because that's given us a step to being able to factor it. Basic things we can factor relatively easy. Quadratics, factor by grouping, things like that. But if I ask you to factor this polynomial, it might be really difficult. So one technique of doing that is long division and synthetic division. Let's look at one more using synthetic division. What is my C in this? It's just 2, right? Plus 2. So 2. Then I set up my coefficients. 2, 13, minus 3, minus 58, minus 20, and 24. What? 0 here. Oh, you say the remainder 0? We ideally hope that, so we can start factoring this 5th degree polynomial down. So we can go through, drop the 2. So we get 4, get 17, 34, 34 minus 3 is 31, 31 times 2, 62, and positive 4, gives me 8, negative 12, minus 24, and 0. Do you guys see that? So if you're a little behind, this is just multiplication. 2 times 2 is 4. 4 plus 13 is 17. 17 times 2 is 34. 34 minus 3 is 31. 31 times 2 is 62. 62 minus 58 is 4. 4 times 2 is 8. 8 minus 20 is minus 12. Minus 12 times 2 is minus 24. Plus 24 is 0. You see that? So this.
So you write x minus 2 times.
So you could say 2x to the 5th plus 13x to the 4th minus 3x cubed minus 58x squared minus 20x plus 24. It could be written as x minus 2 times 2x to the 4th plus 17x cubed plus 31x squared plus 4x minus 12. So this polynomial Could you even guess that if I plug in 2, I get 0? But here you can see if you plug in 2, you have 2 minus 2, which is 0, and 0 times anything is 0. So on the right-hand side, you can see that 2 is a root. And that's one of the things we're going to kind of look at. Roots are where they cross the x-axis. And if x minus c is a factor, then c is a root of the polynomial. And we care about where it crosses the x-axis. We care about these roots.
Why, like, I don't understand with the x to the 5th power plus 32, the one that we did a second ago. Why does it continue when you rewrite it to be the x to the 4th power, the 3rd power?
Here,
Yeah.
so when you're doing synthetic division, you always knock down the power of the first one by 1.
Placeholder, I just don't understand how it like changes.
From the 5th to the 4th?
Yeah.
Because if you do the long division,
But
here this
it's,
x to the 5th, I need, what am I multiplying by x to get x to the 5th? X to the 4th. So you always decrease your power of your original polynomial by 1 because this x term is a power of 1.
Okay.
So instead of,
that's how it works out. With
yeah. So if you see, if I was to FOIL this, this would be x to the 5th. This would be x to the 4th, and I would also have an x to the 4th here. And so I'd end up getting minus 2x to the 4th plus 2x to the 4th. That's where I would get this 0 canceled from. And then this keeps going, of course, and this is 0, 0, 0, 0, and you're left with 32. So all the middle terms are going to cancel, and you're going to be left with x to the 5th plus 32. So this is kind of where we're leading to, and there's a theorem called the remainder theorem. So if a polynomial f of x is divided by x minus c, then the remainder is f of c. So if I asked you to plug in minus 1 to this polynomial, your calculator should tell you minus 14. The remainder is minus 14, right? So if I plug minus 1 in here, I should get minus 14. That's what that theorem is saying. The remainder is the same as plugging in c into the function, right? And the remainder, the value of the function is f of c, right? So if I'm a root at c, then I have to have a remainder of 0, meaning the value of the function at that point c is 0, right? That's the output on the y-axis. I'm on the x-axis, right? My output is y equals 0 at any time I have a root. You guys see that? So another way to kind of verify this is you can plug it in.
Like, do you plug it into the whole thing divided by, or just the
original function.
okay, not the divided by.
Not the divided by part. So you see this function here, my c value is minus 2, right? And when I plug that in, I got a remainder of 0. If I plug in minus 2 to my original function, minus 2 to the 5th power, negative, 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 so it's minus 32 plus 32, that's 0. So it's the same thing if I take the polynomial and plug in c, that's going to be the same thing as the remainder using long division or synthetic division. And that's what it's saying here. The remainder is plugging in c into the function. That's why we care so much when the remainder is 0, because that tells me it's a root. It's going to cross the x-axis there. When I'm graphing it, that's all I really care about. Does it cross the x-axis here or not? This technique gives us potential ways to show it's going to cross the x-axis. Some of these here, it might be a lot faster to do synthetic division than take 2 to the 5th times 2 plus 13 to the 4th, or sorry, 13 times 2 to the 4th minus 3 times 2 to the 3rd minus 58 times 2 squared. I did all this without a calculator, right? However, I would probably need a calculator or be very careful by plugging in, if I plug in 2 there. I have to take 2 times 2 times 2 times 2 times 2 times 2 plus 13 times 2 times 2 times 2 times 2 minus 3 times 2 times 2 times 2 versus doing synthetic division, I get the remainder of 0. Some things like 1 are really easy to plug in and kind of see factors. So this leads us to the factor theorem. And I've kind of been saying this all along, and it has 2 parts. If you're given a polynomial, call it f of x. If f of c is 0, then x minus c has to be a factor, right? If x minus c is a factor, then it has to be a 0. C has to be the 0. Be very careful. It's always in the form x minus c, right? So if I said x plus 2, what am I plugging into the polynomial? I'm plugging in minus 2. I plug in what value of x would make that 0, right? So you have to be a little careful on that, because sometimes students will just take the number. You know, if it was x minus 2, it would just be 2. But if it's x plus 2, you plug in minus 2, because you're looking at what value of x would make that 0. That's what you plug in the function. You guys see that? So this factor theorem will come in handy when you want to make a conclusion. Based on the factor theorem, C is a 0, or if knowing this is a factor, then you can assume that the remainder is 0. So using the remainder theorem, evaluate the polynomial. So I could plug in minus 1 into the function and see what I get, or I can do synthetic division, right? Might be pretty easy to plug in 1 and minus 1, but on 2 4/3, you might want to do synthetic division, right? So let's just do synthetic division for, so x minus c, so c here is playing the role of minus 1. So we have 3 minus 22, 51, minus 42, and 8.
Wait, I thought if it was a -1, it would be +1.
It's negative.
So c, what would be my c here? So x plus 1 is my factor, so c is playing the role of minus 1. X plus 1 would be the factor, though.
Okay.
So if you wanted to make a conclusion, if this equals 0, they say, what is the factor? That's going to be x plus 1. Because when I plug in minus 1, that would give me 0. Yeah. But c is playing the role of minus 1 here. So if it's in this form, you just plug in c. See if I can do the math here. $126. That's going to be the same thing as taking 3 times minus 1 to the 4th minus 22 times minus 1 cubed plus 51 minus 1 squared minus 42 minus 1 plus 8. So you can kind of debate which one's going to be easier to approach. You should get the same answer both ways. This is 126. So this would be positive 3 plus 22 plus 51 plus 42 plus 8. You can do that in your calculator and confirm. You guys see how this is saying if I take the function and plug in minus 1, and this is saying this is the remainder, and it should equal the same number.
On a test and stuff, do you want us to put the minus ones in the parentheses, like write it out like it all is in the red, or do you just want us to leave 126?
I'd like to see your work
Okay.
because you could plug a wrong number in your calculator and I won't know what you did. If you just give me 126, I'll say, oh, if you accidentally hit -1 cubed or somewhere where you're not supposed to, you get a wrong number. I won't know what you were trying to do there. So G of 1, you have two methods. And, we could split the classroom into, halves and say, okay, one of them do it by plugging it in, the other one do it by synthetic division and see which one's faster. And if I plug in G of 1, that's going to be 3 minus 22 plus 51 minus 42 plus 8. Because 1 to any power is 1. Or I can do synthetic division. All right. This would be 3 would be minus 19. What would that be? 51 minus 19. Thank you. Positive 32. 32 plus 42. 74. Did I do something wrong here? 3. Oh, which one? This one is negative. Thank you. Negative 42. So that gives me minus 10, minus 10, minus 2. And that's the same thing as if I take 3 minus 22 plus 51 minus 42 plus 8, that's minus 2.
We do the 2 1.
Yeah, so let's look at the 2. You want to do plug it in or synthetic division?
Synthetic.
Yeah. Plugging it in here is, if you had a calculator, probably no problem. So I have 3 minus 22, 51 minus 42, and 8. So 3, 6 minus 22 plus 6 would be minus, what would it be? 16. 2 times minus 16, minus 32 plus 51, 19. 2 times 19, 38. 38 plus 42, minus 4. Minus 4 times 2, minus 8, 0. We're always happy at this point because we've shown that 2 is a root. Because it outputs 0. They do the same thing, with 4/3. Don't be too intimidated by a fraction. Probably a lot easier to plug in synthetic division with a fraction than it is with your calculator, just because order of operations is so important there. But if you're really good with parentheses, you can plug 4/3 in. If you plug 4/3 in, it turns out we get 0. So G of 4/3.
It would be easier to plug it in or to do the longest division.
It would be easier to do synthetic division with 4/3 and plug it in. If you plugged it in, this is what you're plugging in. 3 times 4/3 to the 4th power minus 22 4/3 cubed. So, it's not necessarily the end of the world, but it's a lot of buttons to hit on your calculator. But here, I take 4/3 and do, synthetic division with 3 minus 22, so forth. 4/3 times 3 is 4, right? And so forth. So if you deal with fractions, it's not the end of the world, but it's a lot easier to do here, less likely to make a mistake doing synthetic division. You should get 0. Let you guys work on that.
So, okay, I've never done fractions on my calculator, so I have to have my scientific calculator to do that, right?
Every calculator should have the ability to do fractions, but it's very important the way you input them. So if your calculator has parentheses, 4 divided by 3, that's going to give you 1.33333333. You're like, what number is that? that's 4/3. So if your calculator doesn't have like a way to transform fractions,
Yeah, this one doesn't.
yeah, I would just use a scientific one and be comfortable with that. Okay, so in the last minute, just to kind of wrap up, we'll do some more of this. We are not going to do imaginary numbers, so don't worry about that. I'm going to pass out the take-home quiz for you guys to work on, and we'll, on Wednesday, since I won't see you on Monday, we'll finish up right here and go on to 3.4, which is zeros of the polynomial.
On Tuesday, are the tutoring labs stuff gonna be open?
That's a good question. I don't know.
Okay.
But it says college closed.
Oh, so it's closed Monday and Tuesday. Okay.
I
all
believe
of it.
so, yes.
Okay.
I would assume not, but
Yeah, I think that they're.
Is that for all of them or?
I'll see you guys on Wednesday. Enjoy your long weekend.
Me too. Do essays and
Oh, I didn't do the sign-in sheet. Oh well, don't worry about it.
Everybody's here.
That's right.